Okay, good morning, e-learners. If you're wondering why there is no period 1 today, that's because we had a fire alarm go off during period 1, and we missed the entire first period, and we got another one of those stand out in the parking lot, very windy. The only thing was missing was snow. But yeah, period 1, we came back to class with about 10 minutes left, so I think most teachers did not do much teaching for the remainder of period 1, but we will start period 2, and we'll get back to normal here. All right, get out your homework.
Can we do 23?
We can absolutely do 23.
Can we go over the whole thing?
Oh no, I'll call out all the answers, but no, you were not, because I walked into the your student advisement yesterday, and you told me, oh, this is easy. Okay, the one drawback in geometry is sometimes going over a problem takes longer to draw than it takes to explain. So hopefully 23 isn't one of those. Let's see. 23. Where is 23?
23 should be on
57.
What? 57?
57?
52, 53.
What? I'm so confused. Where am I?
Andrew's 52, 53.
Oh. Where am I?
No, I'm on the wrong one. No, I'm on the right page. Okay, now we're good. 23 is the proof. So once again, like I said, it will take a little bit of time to draw the shape. So 23 is one proof. And you have this shape. We don't know what this shape is, by the way, yet. We haven't been told.
What is that?
But we are told that this is angle 1 and this is angle 2. And we're told that this is angle 3 and that that is angle 4. And you are given that arcs, that 2 is congruent to 3. So that angle, remember, red arcs, red tick marks mean congruent. So 2 is congruent to 3, and we're asked to prove that angle 1 is congruent to angle 4. Okay, so that's where we're going. I should put that at the bottom. All right, 2-column proof, bottom. Angle 1, and it doesn't even say measure it. Angle 1 is congruent to angle 4. Okay. As of right now, we now have 2 ways of proving that angles are congruent. 2 ways. One was from yesterday's class. We know that one type of angle is congruent to itself. What type of angle? Vertical angles. The only other way we know to prove this is that if we show that the measure of angle 1 is equal to measure angle 4. Eventually, we're going to have a lot of things that I don't need to worry about the measure because I'm going to have lots of statements to say this angle is congruent to this type of angle. Right now, those are the only 2 tricks in our bag. From the picture, what can you tell me immediately other than the given? From the picture, what can you tell me immediately?
1 and 2.
Why? She said 1 and 2 are vertical angles. I didn't say no, but I said why? They're formed by an x and they're opposite each other. Therefore, by the definition, 1 and 2, and we could also say 3 and 4 are vertical angles, right? So from that one statement, I'm not going to write that one down, but we could, right? I mean, that should be your first one after the given. 1 and 2, comma, 3 and 4 are vertical angles. So if they're vertical angles, then what can you say? Right. Well, we can't say that 1 is equal to 4 yet, but we can say that 1 is congruent to 2 and 3 is congruent to 4. So that's how I will start this proof. So we can say that angle 1 is congruent to angle 2, comma, angle 3 is congruent to angle 4. Now remember our given, I got to write the given, otherwise you won't see it proof. The given is that angle 2 is congruent to angle 3. And then the magic green one. If 2 is congruent to 3 and 2 is congruent to 1, then what can you say? This is that transitive thing. If he is the same as him and him is the same as he, ooh, that's a lot of weird stuff, then these 2 are congruent. We can either call this a double substitution or transitive, either one. Hey, anytime I see a 2, I can write a 3. Hey, I see a 2, so I could write a 3. How about the 4? Where's the 4 come from? 3 is congruent to 4. So anytime I see a 3, I can write a 4. Well, I see both of these. I see a 3 and a 2. Right? I'm trying to get to 1 and 4. So instead of writing a 2 for this statement, the given, I'm going to write a 1. Instead of writing a 3, I'm going to write a 4. Why? Because if I see a 3, I can write a 4, and that's how you get to that statement right there. It's either transitive or a double substitution. Either one is fine. We wouldn't say a double transitive, but and we wouldn't even say a double substitution. We would just say substitution. This is the classic case of transitive.
Actually, for whatever reason, they put it in parentheses and said used twice.
Exactly.
Yeah.
Right. Oh, they gave that? Is that?
Yeah, they gave the last.
Oh, that's right. All the steps are here. Why did I? Never mind.
Yeah.
I thought it was a perfectly blank one, but it wasn't.
That wasn't.
But it,
Notice that they put the given as the second statement.
yeah,
I put it as the
that's
first.
kinda weird.
Okay, that's kind of weird.
Yeah.
I would never do that. I always put the given as the first. So let's see. The correct answers for number 23. 1 is congruent to 2. Why? Because vertical angles are congruent. Right? That's theorem what? 2, 3. Or vertical angles are congruent. You're probably not going to remember 2, 3 2 months from now. You're just going to say vertical angles are congruent. 2 is congruent to 3. That is the given. 3 is congruent to 4. Well, that is also vertical angles are congruent. Or 2, 3. And the last one is transitive or substitution. But they said transitive used twice. Okay, that's 23. Questions? All right, let's grade this sucker. 1 through 23 all. I will just grade the even ones. Just the even ones. The odd ones are in the back of the book. Right? And also remember the talk I gave you at the start of class. I already heard a couple people whisper about it. I mean, there's online resources that'll tell you every single answer here. Right? I do not care if you're looking at that stuff, but if all you're doing is copying down the answers and you're not doing your work, which I don't think I see, I mean, the exception of maybe 2 people, right, that I have to continually beat to do their work during student advisement. Most people are doing their work in student advisement, so I know that you're doing this. But if you want to choose to look at those online resources to check your answer, absolutely, positively, especially if you're sitting there like, I don't know the answers to 23, and you're waiting till the next day for me to explain it to you. Hey, get your answers immediately.
23, the answer.
Well, 23 was odd.
Yeah. So,
Okay. All right, number 2. It says make a complement and a supplement. So the complement is 15 and the supplement is 105.
What?
I don't know.
I'm reading classroom exercises.
I was like, what?
I'm about to say,
Hold on.
Even I got that wrong.
Number 2, the complement is 17 and a half. The supplement is 107 and a half. You can put 0.5 if you want. All right. Number 4. So it's the weird one. So if they tell you the angle is 2y, then you can't do anything other than subtract it from 90 and 180. So the complement is 90 minus 2y. The supplement is 180 minus 2y.
Oh, you can actually do the algebra on that.
Well, you could factor it a little bit, but it doesn't really get you much.
It got me to 0. So.
Well, yeah, because you don't know what it equals unless you're told.
Equal length is equivalent to this. And
Correct,
length.
correct.
That's what I don't.
All right. Number 6. Well, 2 supplementary angles are congruent. Supplementary, they add up to 180. So that's not the answer. So if 2 angles add up to 180 and they're both the same, that means each one is 90.
Okay, I got that
You
wrong.
said, you said 19 booms added up to 180.
Oh,
Supplementary. Congruent is 90.
You didn't hear what I said. I said 2 angles are congruent
Yeah.
and they add up to 180. And that means they're both, well, we haven't defined right angles, but they're both right angles. Yeah. We did. 4 was, that was the complement was 90 minus 2y, and the supplement was 180 minus 2y. 6 was, well, 90, 90. 2 angles that are the same that are supplementary. All right, we're on number 8. 2 complementary angles. That means 2 angles that add up. Now, there's 2 different combinations. I'm only going to read 1 letter combination, but there's 2 possible answers there. AFE and EFD. Listen carefully. AFE and EFD. That's one possibility. Or AFE and BFC. Those are your 2 possible. Now, wait, I said CFB instead of BFC. That's the same angle. All right, hopefully you're comfortable now with that. Number 10, 2 non-congruent supplement. That means two angles that are not the same that add up to 180. Two possibles. I'm sorry, three possibles. That's a lot. How about BFE and EFD? That's one possibility. Another possibility would be CFA and AFE. And a third possibility would be DFC and CFB. Remember, you just got to make a line, two angles that are not the same. All right, number 12. That's number 12 in German. Two obtuse vertical angles. That would be BFE and CFD. 14 is, what is it? 155. Good job. 16 is 120, and 18 is 85. I guarantee you I will put that question on the test. I mean, I'll just change the letters around, maybe make it the numbers slightly different, but I will put that question on the test. I will also put number 20 on the test. The answer is 10. Now, just remember that question could be asked two ways. Either find the value of x or tell me how big the angle is. So you solve it, you get 10, plug it back in. Let's see, 30, or 3 times 10 is 30, plus 8, 38 degrees would be the size of the angle. The book just says find the value of x. 22 had an A, B, and a C. A, the two angles would be 153, 153. B would be 180 minus x, 180 minus x. And C, if the two angles are congruent, their supplements must be congruent. That is a true statement. And we just did 23. That's it. All right. Nice short day today. For you get a car. You get a car.
Yes, I like cars. Oh, I don't get a car.
Wait.
You're driving me over.
Bless you, bless you. And before I forget, I need to take roll. I know who's absent. I just didn't.
Number 14 is actually confusing.
Well, because I haven't explained it to you. But I will.
No, I mean on the previous one. Just so you know.
What does it say?
Measurement of ZOW. How on earth are you supposed to figure out ZOY?
Give me 1 second.
Oh, wait, I'm stupid.
Oh, well, that was easy. Say thank you, Mr. Shardy, for explaining that to me.
It makes I'm stupid. Oh, I'm stupid on number 13.
All right. So I just made the statement that today is an easy day. It is. We get 2, if not 3 theorems. I forget. It's at least 2. It might be 3. They are very easy. They are very easy.
Wait, what's the white thing?
That's the day we're on. We are now on Thursday, and we're going to do 2.5. And then, absolutely. That's the next slide. 2.6, 3-day weekend. We come back, it snows, and we're miserable. Then we take chapter test. So we'll come back and do a review, and then we'll take a chapter test. All right, homework for tonight. 1 through 13 all. If you're doing your homework and you're opening the back of the book, and you're like, woo, I got all the odds. I just write down the answer, and that's half done right there. You know, you're screwing yourself as a student. Please, you know, be prudent. I'm trying to think of the better virtue than prudence. You know, be true to yourself. You know, do the work. Even if you can't answer it, at least you have the chance of looking at a problem, not getting it, come back the next day and ask the teacher for help on that particular one. All right. Not too much homework, and this is not a bad class at all. I wish this was a Friday class because we have less time to teach it on a Friday. So 2.4, 2.5, 2.6. Yeah, there's going to be 3 theorems today. We're only going to prove one of them. The other 2 you have for homework. I believe that's right. We'll see. All right. Hey, Book of Truth. We're going to put a definition there. Book of Truth. Open up Book of Truth. Remember, we're going to try to keep this neat and orderly, so you don't wind up with this book of there's just random facts all over the place. 2 months from now, when you have to say something about what we're about to describe, you're like, I remember that back in chapter 2 or chapter 3, then you got a chance of flipping to the right page. You're just randomly putting this stuff somewhere in a notebook. It's more challenging. Okay. If I had a line and another line and they intersect, how many places do they intersect at? 1. All right, that's that one postulate or theorem. And the place where they intersect forms a 90-degree angle. We call the relationship between these 2 lines. Anybody? If they intersect, and they form a 90-degree angle, we call these 2 lines. You've heard this before. Starts with a P.
Perpendicular.
Perpendicular. So the definition of a perpendicular lines, plural, you got to have 2 to make them perpendicular, are lines that intersect at right angles. We have the definition of a right angle. It means 90 degrees. Anytime you see this little square right here, that means 90 degrees. So Book of Truth. So by the definition, if you see this little square, right, you can immediately claim that these 2 lines are perpendicular, because by the definition of perpendicular lines, those are lines that intersect at right angles. Now notice it says lines. Does it have to be lines?
Yeah,
it could be segments, could be rays, could be planes, right? Any of those or any combination thereof. But the actual definition talks about lines, I guess because they're lazy and they don't want to write the rest of that out. All right, let's see if we can prove something real quick. Hey, if this one is 90, what's this one? Why? Vertical angles are congruent. If this one is 90, what's this one? Why this one is 90? Why are they supplementary?
That one's 90. That one.
Okay, he said because they make a straight angle. Notice a line, these 2 angles make that line, therefore, they have to be supplementary. Therefore, if one's 90, the other's 90. So in fact, if one of them is 90, what can you say about all 4 of them? They're all 90, okay? So this is the symbol. Make sure you write that down. You will see that. That is a symbol for 2 things are perpendicular. It could be lines, it could be rays, it could be segments, it could be planes. When you see this little upside down T, bless you, hand sanitizer, please. That means they're perpendicular. Oh, nice. You got your own. Look at that. So AB is perpendicular to line CD. I can't think of a time when things are perpendicular that they won't put a little square. There might be once in a blue moon type thing, but almost always you'll see in our book, when 2 things are perpendicular, they'll have the little indicator that you get a 90-degree angle. All right, now just in your general notes, you can put this in your Book of Truth as well, but just general notes. So what did we say about all 4 angles? If one is 90, they're all 90. If you need to write that down, or you're like, well, that's kind of obvious, that's fine as well too. So all of them. There's some more consequences. Here's another one. If you find 2 things intersect, and if they intersect at 90 degrees, then you can make the converse statement. Well, if they intersect at 90, then therefore they are perpendicular. That's all this says. If any one of these 4 angles, if you can measure it and it's 90 degrees, we're not talking about a protractor, we're talking about some logic, then you can conclude that the 2 lines are perpendicular. So it's the converse, right? The original statement was if this is 90, then they're perpendicular. The converse is well, actually I said that backwards. If they're perpendicular, then it's 90. The converse of that is if it's 90, then they're perpendicular. So that's what the second statement says right here. So this is one of those biconditional ones. We could put an if and only if in this. And then lastly, the statement we said before. This could be any combination of lines, rays, segments, any of that stuff right there. Yeah, they're always going to talk about perpendicular lines, but it could be a plane and a segment are perpendicular to each other. And you will see that this year. Or a ray and a plane are perpendicular to each other. In fact, we will see that today on one of the classroom exercises. We good? All right, we're going to do a really easy proof. Really easy proof. I would expect the entire class, if we put our brains together, I'm going to try to say nothing other than guiding you. We're going to figure this out with I'm not going to give you a hint, oh, this line. We're going to try to figure this out ourselves. Okay, so let's see where we start. It says line L is perpendicular to line N. Notice that they don't put the little symbol over the top Y. They're being efficient. They just put an italicized lowercase letter next to the line, right? There's not two points there to define the line. So we know that we're given that this is perpendicular to that. So that's our start. And we need to say that 1, 2, and 3, and 4 are congruent to each other. And I said, you guys are going to do this because I'm not going to give you any hints. Anybody got an idea?
Sorry, what was the question?
We need to show that all 4 angles are congruent.
So,
Anybody? What? Talk.
I can talk now?
Yeah.
Oh, okay. Since L and N are perpendicular, which by definition, they intersect at a right angle.
They intersect at a right angle. So what can you immediately say?
Angle 4 is right.
So you could say, for instance, angle 4 is right. I'm going to make an adjustment to his statement. Why did he pick angle 4? He also could have said, he said, by definition, if they're perpendicular, they intersect and they form a right angle. And then he said, for instance, 4 is a right angle. He also could have said, or 3. So how about we write instead, by definition, all of them are 90-degree angles, right? And we're going to put measure, right? That's basically what he said. I just chose to write it in a different form. And what's the reason? By definition of perpendicular lines, right? By the definition, they form right angles. How do you show that 2 angles are congruent to each other? Either by a theorem or by showing, either by a theorem, vertical angles are congruent, that's a theorem, or we can also show if 2 angles are congruent, then what must happen? If this angle is the same as this angle, what do you know about their measurements? Say it again. If this angle is congruent to this angle, what can you tell me about their measurements? What does this say? So if all the measurements are the same, what can you conclude? That's what that says right there. So what's the reason for this? If the measurements are the same, they're congruent. That's the definition of congruence. The definition of congruence says this. If their measurements are the same, the 2 angles are congruent. Or it says if they are congruent, then their measurements are the same. You just did a proof all by yourself. And all I did was say, well, what else could he say besides angle 4? And you guys got the rest. So congratulations, you just proved it. Oh, by the way, what did we just prove?
That angles 1, 2,
If you have, that's not what it says. If you have 2 things that are perpendicular to each other, in this case lines, then what? What are congruent? All the angles that are formed by their intersection are congruent, right? That is going to be, since you just proved it, that's going to be theorem 2.4.
I'm just waiting for that one slide that you don't put a human being on.
Well, every morning I go through my slides, and that's the one thing I'm going to remember for the entire year. I hope. I'll say I'll make 4 mistakes. Hopefully.
For the whole year.
On the QED part.
All right. I'm going to keep counting.
If 2 lines are perpendicular, you get 2 things here. Well, the angles formed are all congruent, right? What else does it say? Right? That you also get congruent adjacent angles. So there's actually 2 parts to this. 1 and 2 are next to each other. That means they're adjacent. And since all the angles are congruent, then these adjacent angles are congruent. Why? Because they're supplementary. They form a line, William said. So you get 2 things. Most of the times we do theorems, I'll do this in blue. I'll show you this. All I'm doing is restating this. You don't have to write this down. Some kids, instead of writing this, they write this part because this is going to be an if-then statement. So if 2 lines are perpendicular, you get those 2 statements. All the angles are congruent. All the measurements are equal to each other. Those are the 2 statements you get. There's a third one up there that says the adjacent angles are congruent as well, too. That's kind of the obvious one. I chose not to write that. All right, you tell me. Is that hard to, or easy to forget? Well, what's easy to forget is it's 2, 4. It's not easy to forget that, oh yeah, it's a perpendicular line. That means everything's 90. Obviously 90 is congruent to 90, or 90 is equal to 90. Therefore the angles are congruent. So it's a very easy one. You're not going to forget this one, but you certainly will forget that it's 2, 4. So let's see, what could you call this one? If you couldn't remember 2, 4, and you don't want to flip back, what are you going to say?
Perpendicular lines.
The angles, you could say perpendicular line theorem, okay, something like that. Maybe that perpendicular lines form congruent angles. You could say that as well too. I would know exactly what you mean. Okay. If you put 2, 4, then I'm going to have to open my book because I'm not going to remember what 2, 4 is either. All right. What's the converse to this statement? Somebody? What's the converse? You take this, write this. You take the then part. So take the then part, that becomes your if part. So what's the then part? Just put an if in front of it. If you have congruent adjacent angles, right? If 2 lines form congruent adjacent angles, then the 2 lines are perpendicular. That's the converse. You think that's true or false? Let's think that. So the converse would be if 2 lines form congruent adjacent angles. That means this angle is the same as this one. I kind of drew it where they're not congruent. Yes? So if 2 lines form congruent, so that angle is the same as this angle. 2 lines form congruent adjacent angles, then they gotta be, because if they're congruent and they're adjacent, that was question number what on last night's homework? 14, was it? Is that the one? Where we said, hey, they add up to 180, therefore it's 90 and 90. If they're congruent and they're next to each other on a line, they're supplementary, but they're congruent, well, the only thing that 2 numbers that add up to 180 and it's the same number is 90 plus 90. So is the converse true or false? Anybody want to argue false? Good, because it's true. All right. So the converse is true. Now, generally, as we get later into the book, they're going to write any biconditional statement right from the very start. So this one is biconditional. It works going in this direction. 2 lines are perpendicular. They form congruent adjacent angles. It also works in the opposite direction, the converse. If 2 angles form congruent adjacent angles, then the 2 lines are perpendicular. So eventually, I don't know, chapter 5 or 6, they start writing biconditionals. Up till this point, they don't write a biconditional. They just give you, instead of saying it once and calling it theorem 2.4 both ways, they give you 2 theorems. So the next one is just the converse. Write this one down. By the way, you will prove this. You told me it's true. It is true. You will have to prove this tonight. This is going to be exercise number 2. And I do believe it's a fill in the blank. Yes, it is a fill in the blank one. All right, and Micah said it's pretty easy.
Well, Micah is like,
No? So once again, we get these if statements. So if 1 is congruent to 2, or 2, I left off the other 2. So I can also say if 3 is congruent to 2 and 4 is congruent. I left that off. I didn't want to write all 4 of those. But if 2 angles formed by the intersection of 2 lines are adjacent and congruent, well, then you can conclude that the 2 lines are perpendicular. So it's the converse. It's the converse. Well, that's the second one. I said there were 3. If I were writing a math book, I would have wrote this all as 1 and just make it biconditional. But they chose to write 2 different ones.
Just so they can confuse us.
Well, well, the thing about it, if they give you a biconditional, you got to prove both ways. So when you do one proof, you get double the work. So my assumption is the reason why they do it this way is so that you're not confused and you only solve it or prove it one way. You didn't prove it the converse, and technically you haven't proven the theorem. This way they force you because 2 different theorems prove it both. All right, last one. Look at the picture. Don't read the words yet. Just look at the picture. What do you see? What do you immediately see from the picture? I see a right angle. Do we know it's a bisector?
No.
No. So I see a right angle, and I also see an array coming from the same vertex. So it's cutting this right angle. It could be in half, but we just know it's cutting into 2 parts, yeah? So from yesterday's class, what can you tell me about these 2 angles if this one is right? Can you tell me about these 2 angles? They are complementary. That's what it says. It says this, but it puts a whole lot of extra words around it. But it says, if the exterior sides of 2 adjacent, that means next to each other, acute angles are perpendicular, that's the box, then they must be complementary. So what does that mean? The exterior sides, I just drew them in red. See what I did? The exterior sides are now in red. I have 2 angles. This angle right here, AOB and BOC. So their exterior sides are now in red. If those 2 exterior sides make a 90-degree angle, in other words, if they're perpendicular, then we know that this angle and this angle are complementary. You tell me, is that a big leap of faith there? Right, pretty simple. Visually, with this picture, it's very clear. That angle plus that angle is 90. Why? Because there's a box right there. Duh. We will also not prove this one in class. We'll have this one for homework. I forget which one this one is. Which one is this? Somewhere, is it right here? Yeah. That's number what, 13? 13. So this is number 13 tonight for homework. All right, so remember, once again, all I'm going to do is take this and just write it as a really just straight up if-then statement. So if this ray and this ray are perpendicular to each other, then this angle plus this angle must add up to 90. In other words, they're complementary. That's what you get from Theorem 2.6. Once again, this is more of a dull one. When we use this, we won't use this a lot, but when we use this, it's one of those ones where you will have to search for the reason, right? So this is like a half point off if you can't remember that this is Theorem 2.6 type thing, because this is an obvious one. No one's going to argue, or what's the proof that that angle plus that angle is 90 if there's a box right there. The hard thing is like flipping through your book and trying to find, wait, what is it? What is it? Right? If it's one of those obvious ones and you can't find it, you know, don't spend 5 minutes flipping through your book of truth. Leave it blank and move on. I don't mean that for everyone, but I'm saying something, an obvious one like this. If you literally can't remember that vertical angle, I mean, if you can remember the vertical angles are congruent and you're trying to find out what theorem that is, right? Just put vertical angles are congruent. Just put, what's another way of writing this with words instead of trying to find it's Theorem 2.6. Give me some words. Instead of trying to find that this is Theorem 2.6, which you, at this point, you have to, give me some words to describe what's going on here for a reason in a proof. We've got to give it a name. We've got to give Theorem 2.6 a name. No one? What do you visually see is going on here?
There's two acute angles that are perpendicular.
Okay, so if you can't remember 2, 6 and you're flipping through your book, then just write what you think it says. 9 times out of 10, you're going to write a lot of words for the reason, but you're going to get it right. Hey, I got 2 angles that they add up to 90 degrees, right? And if you can't remember that's 2, 6, then at least we're making some progress. All right, you guys are dead today. I mean, like really dead. All right, so this is number 13 tonight for homework. All right, so remember, to get a C in this class, you have to have skills. To get a B or an A, you got to be able to do proofs. So let's talk about the skills that we just learned today. What skills did we just learn today? Tell me one skill that we learned today. What? No. I mean, specific skills. What did we just learn? That, what can we say? Okay. We were certainly talking about perpendicular lines. What can you now tell me about perpendicular lines? Right. If you form perpendicular lines, then all the angles are congruent, and they also are equal to 90 degrees. There's one skill right there, right? So if you have that shape right there, and you're told that, then all 4 of them are, right? The measurement are equal to 90, and all 4 of them are congruent. Give me something else you now know from today's lesson. This is the skill. Tonight for homework, they're going to ask you questions. You're going to have to know these skills. Yes, there's 2 proofs, but let's make sure we can do the skills. What else do we know or can do now? You got to participate. Let's go. Give me something. Anybody? Nothing? Give me something that you learned from today. I gave you 3 theorems. Flip back through your book. Tell me something. Anything. What you got, Wes?
If they're both sides of
Okay. If they are perpendicular, then the 2 adjacent ones are supplementary, right? They're both equal to 90. You're like, well, isn't that the same thing? Well, it's a different statement. So there's our first one. The 4 angles add up to 90. They're congruent, and they're equal to 90, right? The adjacent angles are complementary to each other. I should say supplementary. I should say supplementary, not complementary. The adjacent angles are supplementary. These are not the droids you're looking for. I should say the word supplementary. Okay. You said it. That was good. Both of you came up with 2 things. For those of you that worried, am I going to pass this class? You got to know the skills. These are the skills. What else? What was the last theorem that we did? What did it have to deal with? What was the last theorem? Come on, you guys can look at your paper in front of you. You just literally wrote it down 5 minutes ago. And you can tell me something about it. So we get this shape right here. If I give you this shape, what can you tell me about these 2 angles? Somebody help me out.
They both equal the same thing.
Well, they might. There is a case. If both are equal to 45, that is true. But if it's just this and they tell you nothing about it, though, you can tell me what? If you see this shape, what can you immediately tell me?
Both sides add up to 90.
That both of these angles added up are 90. Hey, if this is how this class is going to be, like every single day, this will be your, maybe Mr. Brubaker and I will argue which one's the most boring class, right? You got to participate. This is how you're going to get a C or higher in the class, is if you can look at these statements and pull this stuff out. I can be as animated or loud and yell as much as I want, but you guys got to be part of this process, right? I can pull only so much. There's got to be some willingness to walk with me through this material. So let's do that. Open your books to page 57. Let's walk together and let's do some of this. Open it up to page 57. when we're doing this, if I call on one person, you don't turn your brains off and say, "Whew, I'm glad he's not calling on me." Right? Share. Try to come up with the answers. I don't do this every single class. Most classes, I don't finish the lecture in time to go to the classroom exercises. But this time I can. So let's do this. In the book, if you see something that is not colored, it's in 2 dimensions. If you see something that's colored, 9 times out of 10, it's in 3 dimensions. So this second picture right here is this. Here's the plane. You see OZ? That's OZ. So this is the shape that they are trying to draw right there. You got these 2 lines that are on the plane. You got this other one that's coming off the plane like that. Can you see that? Whenever you see color, 9 times out of 10, it's because they're trying to say it's in 3 dimensions. Remember, they got to draw it in 2 dimensions. Okay, here we go. Chris, you get the first one. Number 2 in the diagram, AB. Oh my word, look at all those lines there. It's confusing. There's too many lines there. So one thing you can do with your pencil, lightly erase after you're done, is highlight. It says that AB, that's this one right here, is perpendicular to CD. Okay, a little bit clearer now. EF, maybe in green, EF is perpendicular to CH. You got it. Good? Chris, tell me one of the 8 right angles. Then we're going around the room. I want you to look at that shape and tell me one angle that's right. AOD, next. Apparently there's 8 of them. BOD, next.
EOH.
EOH, next. EOG, next. I've forgotten what they said. Give me a right angle.
A right angle.
A right angle.
FOH.
FOH, give me a right angle.
GOF.
GOF. We good? All right, you can confuse yourself if you're not writing down. All right, that wasn't too bad. But certainly, if you leave it like that, it's bad. All right. Wes, this one is yours. Remember, by calling on an individual student, you should be trying to get to the answer. In the diagram, OZ, that's the one that comes straight out, is perpendicular to PQ. Well, it's also perpendicular to XY. And PQ is perpendicular to XY. That's a lot of things. Give me a right angle. XOQ. Doesn't look like it's right from the picture, right? That's because they took a 3-dimensional object and they're drawing it in 2 dimensions. These look like they're right angles, right? This one does not. This one looks obtuse. It actually is right. Good. Give me a right angle. ZOY does not remotely look like a right angle, right? It's a little tiny angle right here. But remember, the real picture is this. And so, I can't do this, I need a third hand hold. So, you're talking about this angle right here. From here to here, that is certainly a right angle. Good one. And that's the one that most kids would say, that's not a right angle, that's like 20 degrees. Give me another one. Say it again? POX looks acute, but it is right. One more, Connor. XOQ. All right, I think somebody gave me that one. Give me another one. ZOX. That one looks crazy obtuse. It's right. Hey, guess what? They're all right angles. With exception of the line POQ, there's no angle up there that isn't 90 degrees. Okay, that's not too bad. This book likes tables. This book likes tables. I'm going to say nearly every single homework exercise will have a table. Some of the tables are really easy to figure out. Some of them are challenging. I try to at least show you some of the tables. So here we go. So this one's Madison. Let's see. In the diagram, BE is perpendicular to AC. BD is perpendicular to BF, so that's a little bit harder, so I'm going to do this in color. So we know that this is that, hey, we can put a little that, but it's going to get really crowded, right, if we do that. So I'll leave that off. And then we're told that this is perpendicular to that. That was a little bit easier to see, okay? All right, so let's see what the table has us doing. Find the measurements of the following angles, C, B, F. So green. C, B, F. How in the world are we supposed to figure that out? Oh, it tells us. It tells us that CBF is 40, right? What in the world is this row for right here? What could that be?
Oh,
It says find the measures of the following angles. So I don't even know what it means. Let's do this row first then. So it says CBF is 40. So that means CBF right here is 40. Okay. Then it says EBF. EBF. What do you think? Where are you getting that from? That's a teacher thing. What? It's right angle. This is theorem what? Look in your book. It's theorem 2-6, right? If two angles are adjacent and they are perpendicular, their exterior sides are perpendicular to each other, then they're complementary. So you're right, that is 50. So this one's 50. Okay. DBE, who are we on, Cadence? DBE. DBE. Where are you getting that from? Because remember the 2-6, red is also right angle, so that means this is 40. All right, now we're making some progress. DBA, Connor? Tell me how I would get to the answer, and I'll do it for you. DBA is right here. How would I get to that answer? What do you notice about ABC? How many degrees in a straight line? How many angles are we missing now that don't have a label on them right now? It says 40, this says 50, this says 40. How many do not have a label on it? 1, 2, 3, 4 angles. How many angles do not have a little green mark next to it? 1. And you just told me that all of them added together is, could you solve that? If you're only missing 1? Okay. They all add up to 180, and I got 40 plus 40 is 80, plus 50 is 130. Therefore, this one is 50. Okay. And that one's 50. You're going to see that all the time. And then DBC. All right, now we got to do some. DBC would be what? This angle plus this angle plus this angle is 130. Is that right? 80, 130. Okay. All right, who's got the book open? What the heck do they want us to do for 5? It doesn't say anything. I have no idea what they want us to do there. Okay. Oh, yes, I do. I didn't even see this. What does that say? So we're back to the previous homework. If this one is X, then what's this one?
X plus 10.
No. What is EBF? EBF is the complement of this one. See that? EBF is a complement of this one. So guess what this one is? 90 minus, there you go, so forth and so on. So what's DBE? DBE, the complement of this one. So what is it? Oh, by the way, I got to erase these now. Now that we know this one is X, this one is 90 minus X. So what is DBE? Oh, this is hurting my head now. I'm going to draw it. You know that this is 90 minus X, so what's this one? Where are you getting an X from? Well, This would be 90 minus this one. And this one is 90 minus x. 90 minus 90 is, so it's just x. You tracking? All right. The rest are done the same way. These tables are going to kick your butt this year. Usually the first one is the easy one, and the second one is they throw variables in there, and it causes you problems. Okay. All right, questions on the table. For homework tonight,
No, please tell me.
there are no tables.
Yes.
All right, be ready for the tables. They will start soon enough. All right, let's finish this one up. Who we leave off on? Go. If angle 6 is a right angle, then RS is perpendicular to TD. How come I can say that? Which theorem? There's only 3 of them. Look to your right. Look to your right. Down at the book. There's only 3 of them. Bottom of page 56. Which one says that if one angle is right, then the 2 angles are perpendicular? Which one says that if 2 angles that are next to each other, to what? 2,6 does not say that.
2,5.
2,5 says that. Notice what it says. If 2 adjacent angles, right, form a right angle, then the 2 are perpendicular. Yeah. All right. Yeah. This diagram. So ADB, like 2x minus 15. And read. Okay, fine. Okay, so that was 2x minus 15. And DB is x. Okay, right there. What do you know about this thing and this thing? What do they add up to? Just put this plus this equals 9. All right, e-learners, if you have any questions, don't hesitate to ask. I will see you guys tomorrow.
Why do tables exist? That's my question.
To make all of our lives challenging and uninteresting. I don't know.